my mistake. Okay. Okay. We will do it. Okay. I'm sorry. Sorry. Yesterday also I missed it, but generally yes, I record all the sessions. Okay.
Thank you.
So no problem. So again, we'll talk about it so that it gets recorded. So we spoke about quartile. Okay. So first we spoke about median. Median divides the data set into two equal halves. Quartile divides the data set into 4 parts. Okay. And when we talked about box plot represents these 4 parts. So box plot is in shape of box, okay, rectangle. Then you have a line in between, and then you have 2 handles like this. Okay, so what this is called horizontal box plot. Box is sleeping, right? You can have vertical box plot also. So in vertical box plot, you will have something like this. Okay, standing. You'll have standing box, okay, handle here at the top, handle here at the bottom, and a line in between, right? So here it talks about quartile 0 or the minimum value of the data set. Okay, the minimum value of the data set Q0. This is quartile 1, the data set that divides the number that divides the data set into 1/4. So in this our example, 20 is Q1. Okay, so this will be 20. The minimum number in data set is 10. So this is 10 in our from this example that we have in Excel. 20. So 20 is dividing data set into 1/4 value. Here this is called Q2. Q2, and it is same as median also. Okay, so this will be 40. Okay, actually 45 in our case. Okay, this is 25, not 20, 25 basically, right? Q2 we calculated 25, isn't it?
Yeah.
So 25, and this is your 45, and this is 65, and the handle is the maximum value of the data set. So it is 80. Okay, so maximum and minimum we don't have to calculate, we can get from the data set.
Yeah.
Okay, so minimum value is 10, maximum value is 80. Okay, now this is called box plot. Okay, you can have vertical or horizontal. Okay, why are we reading box plot? Why are we talking about box plot now? Because box plot, okay, is the probably the only simple plot which also identifies the outliers. What are outliers? Outliers are the numbers which does not generally conform with the numbers that we have. Okay, so in this data set, let's say we have values from 10 to 80. Let's say the last value is like 500. Right? Now, this is kind of outliers. Okay. Any other plot you draw, line graph, bar graph, histogram, all those things will include 500. But box plot has the capability of identifying this. So what box plot will do is it will put a dot here. Okay, 500 will not be Q4. Okay, this will not, it will not look like, this handle will go on till 500. So box plot identifies the outliers and it will exclude it from the box, and it will mark. Okay, it's not that it is going to ignore the number. It is not going to ignore the number. It is going to put it here on the graph somewhere. Again, you can have outliers on the lower side also. Let's say minus 50. Okay, 500. It is going to put it on the map as dots. So if I go to our say Chrome, and in Google we type box plot. Okay, let's take some example of box plot. Images. So yes, okay, so yeah, so there's a couple of more things here. We have something called as range. A term you'll see, range. Range means max minus mean. Okay, so what is range here of this data?
70.
Correct. 80 minus 10, 70 is the range. Then you have IQR. IQR is called interquartile range. Interquartile range is nothing but Q3 minus Q1. Okay, quartile 3 minus quartile 1. Okay, see, range is nothing but Q4 minus Q0. Q4 minus Q0. Okay, so Q0 is minimum, Q4 is maximum, so range is Q4 minus Q0. IQR is Q3 minus Q. What it does is, it says, okay, let me leave out 25% data on the lower side and 25% data on the higher side. What is this difference? In this case, it is 65 minus 25, which is 40. IQR is 40. Okay, so IQR is 40 here. Right. So reason why we use IQR and range is to see how much data is how much is the variability. Okay. But IQR we're trying to remove. So generally what happens is when you have lot of data, thousands, millions of data, it is possible that there would be some junk data. Even if it is not junk, there will be some data which, okay, so I'll give you an example. When we used to handle company data, public companies, financial numbers, okay, and we used to look at globally $10 million, $15 million companies till the maximum, right? And we used to download the report. We used to get like 35,000, 45,000 companies, okay? 35,000, 40,000 companies are there, worldwide public companies whose revenue is more than $15 million. So when we download that data, what happens when you look at, say, profit margin or revenue margin, okay? There would be definitely some outliers, okay? See, generally profit margin would be like 30%, 40%, 50%. But there will be companies with 200% profit margin, 300% profit margin on the higher side. Small company, and let's say, that year they did very, very, very well, 300%. And at the same time, on the lower side also, you will have some minus 100, minus 50, minus 60. Now, these are numbers we can clearly see that these are not the, normal numbers. Maybe that is something bad happened to the company and they got, because we are talking about 40,000 companies, there will be some which has done very well unexpectedly, right? So they'll have very high value. So when you remove this quartile data on the higher and lower side, these kind of numbers will go away. Right? That's why. Okay. Otherwise, range would be too high. 200% minus 100%. 300% would be the range. 300% range profit is too much. Okay.
Yeah.
In that case, we will remove those two so that we get kind of average value. So if you remove Q3 could be around 50%. Q1 would be around 20% or 10% or 15%. So we say okay, 40% variability. So that's why we use IQR. We tend to remove these values which are very high or very low. Okay. So that's why it's IQR, and that's why box plot will have some outliers. So now let's go back to this. Let's study this. Let's see what this talks about. Okay, so this is what you have experiment number. So there are 5 experiments and speed of light. Okay, so they have calculated the speed of light. So see, in the experiment 1, this is the handle of the box. So this is the minimum value that they got, and this is the maximum value they got. You see, there is a dot here. That means it also got a outlier which is very low. Box plot can identify the outliers. Here, there is no outlier. Second experiment. Third experiment, you see, there are 2 outliers here, and also 2 on the higher side. So box plot, otherwise, you see, normal graph would have included this box, but box plot can actually figure out outliers. So, and outliers are represented as dots here. Okay. So, this is how the box plot is used. Okay, and we're talking about box plot because this can identify you. So when you plot the box plot, you can see these dots and you know that these are outliers straight away. Okay, without using any complex formula. Right? Okay, the box plot can tell you the outlier.
Yeah. Actually, I had a question over there. Like the median line in those box plots of the second and fourth test, the median line was not at the center, like it was
It
offset.
may not be at the center. See, in this data, if you draw, you will get at center. Okay. Did I close it? Okay. It need not be at the center. See here, best example is this one. So it tells you the spread. Okay. So it means if you see here, there's between Q1 and Q2, right? The gap is very less. For example, here you see there is no Q1. Q1 and Q2 overlapping. The handle is not there here, right? The handle is overlapping. That means Q2 and Q1, okay? I mean, Q2 is here. Q1 and Q0 basically, okay? First quartile, there is all the values are like 25, 25, 25, 25, 25. Okay? The spread is almost zero. For example, in this data set, let's say you have 30 here, and this is also 20, and this is also 20, let's say. 20, 20. That means Q0 and Q1 is same. Q0 is also 20, and Q1 is also 20. Right? So there is no spread. See, smaller the gap, less is the spread, less is the variability. Bigger the graph, bigger is the variability. Okay, on that lines, okay, just give me a second. I'll quickly open example which I have on Boxplot, and we can talk about it. Okay, just give me a second. Just give me a second. Okay, this is the slide I have. So, okay, see, this is the box plot, okay? And this is about the service time of different quick service restaurants. So you have Popeyes, Wendy's, McDonald's, Hardee's, and Jack in Box. Okay, and this talks about the service time. So you have 95, 95, 95, right? Now see the box here. Here what it means is, let's assume this is 100, right? So from 100 to 150, okay, 1/4 of the customers that they get, 1/4 of the customers are serviced between 95 to 150 seconds. Okay, then this is for the next 1/4, next 1/4, next 1/4. So if you see here, the range indicates, okay, the range indicates that values are far spread. So you see, it's like this is the land. Okay, now let's say this country has 100 people or 100 houses. Correct? Let's assume that this is a country, and this is the spread of the land, and they have 100 houses. Okay, that means the first handle will have 25 houses, 25 houses, 25 houses, and 25 houses, right? Because quartile is equally dividing the numbers, okay, irrespective of the value. So bigger plot means the houses are spread far away. You get it that way, because you have to accommodate 25 numbers. If the line is bigger, that means more spread is there. So between 10 to 100, you have 25 houses. Now from 100 to 150, you only have 25 houses. So here, the numbers are very close to each other. Houses are very closely situated. You see here, Hardee's. What Hardee's says is first 25% customers, there is hardly much difference between 25% customer. But if you look at last 25 customers, last 25% customer, the service time varies. Right? So the number of customers serviced is same in each of the 4 parts, but duration is bigger. Okay, so numbers could be like 25, 35, 45, 55. Here, less range means 20, 21, 22, 23. You know, that way you can assume. Okay, this is like land and you have houses on here.
Hmm. Okay.
Okay, so this is the advantage of using box. And you see here dots, these are outliers.
Hmm.
This is outlier here.
Hmm.
So Hardee's has one outlier, Wendy's has 3 or 4 outliers. Here maybe 2 values are there. Here 3 values, maybe 5 or 6 outliers are there. And none of the others have outliers.
Hmm.
Okay.
Hmm.
So that's how we study the box plot, and it actually helps us to analyze. Now going back to, I think I deleted the code which I ran yesterday. Okay, nevertheless, let's read the same data set. Okay, and let's try to see. Okay, so total. Oops, sorry. Okay, so let's say df. Okay, first we import conduct as pd, and I say equal to pd dot read csv. Okay, now we have a data set. Hmm, okay, so we will look at some numbers. Okay, 1, 2, 3, 4 numbers. So there is here a not okay stays in weekends, let's say, or stays in weeknights. Okay, so let's talk about this data set. This column basically. Okay, and what I'll do is I will say df of this column. Okay, and dot so, so df dot say box plot. Okay, so to draw we'll say df dot box plot. Okay, and then column, on which column you want to make. Okay. Column. Okay, column equal to, and I'll give this column. I want to make box plot on this column.
And is box plot a part of pandas?
Pandas, yes.
Okay.
Okay, and here we will say import. Okay, import this matplotlib, right? So import matplotlib dot pyplot
SPLT.
matplotlib dot pyplot as plt. Okay, and now here I will say plt dot show. So you see this. So what it means is, okay, so here 0, right? If you look at the data set, bulk of the data is like they're staying for 5 nights only. But you have something like 17, 15 nights also. These are being classified as outliers.
Okay.
Right? And okay, so that means minimum they have is around 0 night. So the 0 weekend night. That means these people are staying only night. So 1/4 of the people that they count stay on weekends. Weekdays. The weekend night is 0, isn't it? That means they came and they left in the weekday itself. They didn't spend any night in the weekend. So 25% of the customers, okay, if you remove the outliers, then okay, so it has, we saw that it has 119 or 120K, right? 120, not 1 lakh, right? 11 lakhs, correct? So 120K record. Out of 120K record, we have only 5, 8, 11 are outliers. Rest are all analyzed, and 25% of the data of all the customers, okay, moved out within weekday. 75% customers actually spend time on the weekend. So most of the traffic comes on the weekend. That's what you can see from here. Right? 75% customers comes on weekend. And that too, okay, another 25%, okay, left within a day of weekend. Okay, the last 25% customers actually have spent almost 3 days, 3 weekends. Right? So this is what you get, and you can remove these values. So you can say, so you see that value is 5. So we can delete or drop the data which is more than 5 days. Right? So you can say drop, okay, access equal to 0, which is more than 5 days.
Okay.
Right?
Yeah.
So you can do that. You can drop duplicates data. Okay. You can drop duplicates data as well. Okay. But what is more important is, okay, is this scaling. Okay. Scaling is very important. What does scaling tell us? So, okay, so let's say we have a data set, okay, age and salary, let's say. Age will be in 2 digits, right? 23, 26, maximum 60, right? Age will be in 2 digits. But your salary will be in 5 to 6 digits, right? So if you take out annual salary, let's say 90K, let's say, 140K. Okay, even if it is 50K also, lower, like say 45K also if you take, this is still higher than the age. Right? Now, within age, it's fine. Within salary, it's fine. Okay, they are in the same range. So these are not outliers. Outliers we check within the same column. Right? But within different columns, they are not outliers. Okay? So so the numbers are fine. It's not outliers that we need to remove. But the problem here is, okay, problem here is that when you input these as features, okay, features is like X values, right? If you input them as features, salary will tend to create bias towards itself because it has a higher value. And in mathematics, when you have a 2-digit value and 5-digit value or 6-digit value, 5-digit value, the heavier value will try to create bias towards it. Okay, so if let's say based on age and salary, you want to predict if your customer is going to buy a product or not. Let's say your predictor is buy, right? And you say yes, okay, yes, and no, right? So machine learning algorithm is nothing but mathematics only, some formula itself. So these will tend to have higher. So what happens is, if we do not handle it in the step, it might say that, okay, age is very small number, so let's ignore age. Okay, age will be ignored, only salary will have impact on buy, which is not right. We want age also to have similar impact. So what we do in scaling is we actually scale the values in such a way that they are in same comparison. They are not in different numbers. Okay, so let me take out the Excel again and talk about it. So let's say you have age and we have salary here. Okay, so see, if you have something like expenditure, let's say expenditure and salary. Expenditure would be in 5 digit and salary will be in 5 or 6 digit, right? In this case, you don't have to do scaling. Okay, let's say it's 40 and let's say here it is 80. Yes, there is a difference, but of course you can do scaling or you can ignore to do scaling. Okay, there's not much of difference. But when you have age, which is like 20, definitely you have to do scaling. So there are two types of scaling. One is called min-max scaling. Another is called Z scaling. Okay, min-max assumes that minimum value is 0. Okay, and maximum value is 1. It assumes that minimum value is 0 and maximum value is 1. And all the values are written. Let's say if you have 20, 22, 28, 60, 55, 45. What it does is, this will convert 60 to 1 and 20 to 0. And accordingly, all the values will be converted between 0 and 1.
Okay.
Okay. Similarly here, let's say if you have 80, 120K, okay, 78K, 55K, 40, 34, 21. Now in this case, you see, this is minimum. So this will be converted to 0. Okay, and this is maximum. This will be converted to 1. And everything else will be proportionately converted a value between 0 and 1. Okay, so now what happens when you compare? So this is your age column, right? New age column. And this is your new salary column. Okay, so within the same column, we are maintaining that proportion basically. Within the same column, we are maintaining the proportion. Right? So what is highest will remain highest. What is half will remain. So if you have something like 60, right? Here 60, let's say this is 60. So this will be 0.5. Right? Half of it. So we are maintaining the same relationship within the column. And with respect to two columns, we are in same range. So we are making them equal. So now when you input this, okay, we are still in pre-processing step, right? So now that we put it in the analysis, the age and salary will be equally matched in the analysis. Salary will not tend to pull the data towards it, analysis towards itself. It's not going to create that biasness.
Yeah, understood.
Right? So this is called scalar. Okay, so min-max scalar will have 0 and 1. Z scalar depends, comes from a statistical factor where value will be ranging from -3 to 3.
Okay.
Okay, and what we say is 99.996. This is 3 sigma. 3 sigma is like 99.5, I think, or 99% or 99.5%. So data will be between -3 and 3. There could be some 0.1, 0.5% data could also be beyond -3 and 3. That's fine. But the value ranges from -3 and 3. Here we take standard deviation. Based on that, we calculate. So maximum value, this will be something like 3. Okay, and this will be something like -3. And all the values will range from -3 between -3 and 3. Okay, so just give me a second. I'll take out this this document. Okay. Okay, so you see that. So we use sklearn. Scikit-learn is the library in Python that we use to perform, machine learning. Okay, it's called scikit-learn. Sklearn is the package. And this is theory about what is machine learning, right? So what is machine learning? What is human learning, right? So if your today's knowledge is more than yesterday's knowledge, then we say that you have learned something today, isn't it? Something that you didn't know today, I mean, you didn't know till yesterday, but you learned today. Then you say that you have learned something, right? So if we measure the performance, if I take a test of you, okay, yesterday I would have taken a test, and today again I have taken the same test. So questions remain same, okay? And then I see your performance. If you performed better than today's test, then that means you have learned something. That's why you have been able to perform better on the test, isn't it? So same questions if I asked yesterday, and same question if I ask you today. Today, if you have performed better, that means you have learned better. So that's what it says. Okay, so same thing happens with data. Sorry, computer also. So we say the machine is learning or computer is learning when a computer is said to learn from experience E. Experience E is nothing but the data. Okay, with respect to some task T. So T is same, the test. Okay, I give you a task to do it, like test. So if E improves, the experience improves, your performance P also improves. Experience improves. So today, you learn something new from yesterday. So your experience increased on the same task T, your performance P also increased. We say machine is learning. So if you provide more and more data to the program, to the computer program, and the performance increases, we say that machine is learning. Same concept. Let's speak about supervised and unsupervised yesterday. Same thing, banana, apple, cherry, grapes. Okay. Yeah. So same thing that we discussed yesterday. This is the same slide that we discussed yesterday.
Yeah.
Okay. We talked about AI, machine learning applications. Okay. So scikit-learn is the package that we use for machine learning. Okay, and it is based on your concept of probability. Okay, this is about how to use all those things, Jupyter and things like that. Fine. Okay, so pre-processing. So this is simple data set. So here, this is the first thing that we spoke about. Scaling. We also call it as feature scaling. Okay, so when do we do it? When we see that the features which are there, right, the X values, the columns in the X values of the features, if they are varying by very high value, right, if it's 2-digit versus 4-digit or 3-digit, that's when you will perform feature scaling. If they're in same range, you don't have to do scaling. The reason, right, why we need to do it. So this is called normalized or mean max scaling, which I saw. So the X is X minus mean of X by max of X minus mean of X. So it says, let's say if you talk about here, it is X minus, so on numerator we have X minus mean of X. Okay, and that you divide by max minus mean. Okay, so in this case, the age would be, okay, X is what? 20. Okay, so let me do it. 20. What is minimum? Minimum is 20 only. So 20 minus 20. I mean, if numerator is 0, 0, anything will be 0, right? But let's calculate. Okay, 20. So 20 minus 20 divided by 60 minus 20, right? Max minus min is 40. So it is 0 by 40, which is 0. This becomes 21 minus 20, 1 by 40. This becomes 28 minus 20, which is 8. 8 by 40. Okay, this will be 60 minus 20. So 40 by 40. 1. Then 55. So 55 minus 20 is 35. 35 by 40. 0.875. This is 25 by 40. Okay, so this is how mean max will convert between 0 and 1. Okay, the second method is your Z score normalization. So here we figure out X minus mean divided by standard deviation. X minus mean by standard deviation. Okay, so let's take age only. Age using mean, this one. So mean is what? Mean, you have to find mean and standard deviation, you have to find standard deviation. So standard deviation is STD DEV, right? This is the formula in Excel. Standard deviation of these values. Oops, what happened? 22 to C2 to C7. Why? What is happening here?
OD only make
It is not treated as numbers. STD dev should give us the value. Okay, let me say 20, 20. It's working. Let me see, something is wrong here. Numbers. I don't know. Okay, let's ignore it for now. Okay.
Yeah.
We'll probably discuss some. So let's say you get standard deviation of 5. Let's say. Okay, and mean you get 38. So value will be X minus mean divided by standard deviation. Minus 3633. Okay, same thing. What I'll do is I will fix G9 and G10. Okay, so standard deviation will be more than 5 definitely. Okay, let's make it 10 here. So this will be your new value here. So this is using Z normalization or Z scoring or Z scalar. Okay, using Z scalar, this is how we are normalizing the values. And this is using mean max. Okay, so generally this is preferred, but you can do anything. You can do this one also. Okay, there is no restriction as such.
Okay.
Okay, and this is the example you can practice. Okay, simple example is there. You're taking a numpy value and we're scaling. Okay, and we'll take one example and we'll do it. Okay. Okay, so missing data, same thing we are taking all these np.nan. Nan we are replacing with a mean value. Okay, so we are saying strategy equal to mean. See, yesterday what we did was we did manually. Okay, using scikit-learn. Scikit-learn has a class called simple imputer. Okay, within one line it will replace all the missing values with mean. Yesterday, like we did each and every step, we did for loop, we replaced it. But scikit-learn has one single line which will help, which will simply replace the missing value.
Okay.
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 Then handling outliers. So same thing, we used box plot for visualization. Okay, and it will be able to tell us, okay, these are the values. You can even use scatter plot. Okay, so this is using visualization technique. Or to visualize and remove the outliers. You can also do it using z-score. Find the z-score and you can remove it. Okay. Now these are simple programs here. You can actually practice. I'll share this.
Yeah, sure.
Okay. And this is how you can remove the outliers from here.
Oh, this was the third point that I forgot yesterday. Categorical data.
Yes.
That we were going to discuss.
Yes. So see, for missing data of this is easy. What we did was we can either replace with some specific value or we can say mode. Right? We have to calculate mode and then replace the missing values with mode. Yesterday we did, right? Most occurring value. Remember the last before ending we actually did categorical value only.
Yeah. Oh yes. Yeah, we actually did. Yes.
Yes. Right.
We found out like which were the common ones. Like BB was the common yesterday, and then we replaced the missing ones with BB. Yeah, sorry, I forgot about that.
Okay, so but what we didn't discuss is how to handle this categorical value. Mostly categorical values will be in text. Right? So one thing is that the categorical value will be in text. So mathematics can't take it, so you have to convert into numbers. Okay, so let's say let's take an Excel only. Let's say your column is region. And here you have north, south. Let's say data says north, south, east, or west. West, east, west. Let's say this is the column and these are the values. Now machine learning cannot take or mathematics cannot take text as input, right? So you have to convert into numbers. So categorical values, mostly it will be in text. So what we do is we convert into number first. Okay, so number would be, so first step is that we are converting into numbers. Okay, so here since E is the in alphabetical order E comes before everything else, right? So we will call it this as 0, east as 0, then comes N, right? So we'll call north as 1, south as 2, and west as 3, right? So east is 0, 0, 3, south is 2, north is 1, 1, 1, 2, 1. Okay, so text, since we can't use text, I have to convert into numbers. So we convert it into numbers 0, 1, 2, 3. Now, what is the problem with this? What could be a problem with this?
I mean, maybe it will treat West as like higher.
Exactly. Okay,
Yeah.
that's the problem with. Okay, problem with categorical value when you convert into numbers. See, technically speaking, okay, north, south, east, west, the numbers in itself, okay, or the value in itself has to have equal importance. But when we convert into 0, 1, 2, 3, it looks as if east has no value at all, correct? And west has, is very superior. Is, it's like 3. Okay, so when we enter into this, see, in the scaling, something like scaling. In scaling, within the column, it's okay. We actually mean when we say that height or salary is 20K versus 60K, we do mean that 60K is 3 times that of 20K. So there is not a problem. But here's the problem: we are not, south west is not 3 times more powerful than east or north, and east has no importance. East is 0, has no importance.
Yeah.
So we have to negate the meaning of this, isn't it? So what we do here is we convert these values, okay, which is one column region, into multiple columns. So north will become one column, south will become one column, east will become one column, and west will become one column. So one column region actually got converted into 4 columns: north, south, east, west. Okay, and what we do is if this row, okay, you have other columns, right? You'll have other columns here, isn't it? So now in this row, north is there. So you put north as 1, rest as 0. Then this one has south. So you put south as 1, rest as 0. North 1, so put north 1, rest as 0, 0, 0, 0. Again, north 1, 0, 0, 0. North 1, rest 0, 0, 0. South is, right? South is present. So we are saying 1 means present, 0 means absent. Right? South is present, rest is 0. East. So we'll put east as 1, the rest as 0. West. So west as 1, rest as 0. East again. So west is 0, east is 1, west is 0. East again, 0, 0, 1, 0. West. So west is 1, west is 0. Right? So one column got converted into 4 columns.
Right.
Okay. One column got converted. So this is the step 2. Step number 1, we convert text to numbers. Step number 2, one column got converted into multiple columns. Okay, and here we're talking about what is present, what is absent. Okay, and what we do is, see, when you say 1, 0, 0, 0, it means that there could be a situation where all of them are absent also, isn't it? This we call it as dummy variable trap. Okay, so it also means there is some other 5th column which is present. That means rest everything is absent. So to remove, to not to fall into this dummy variable trap, what we do is we say after converting into 4 columns, you remove any one column. The meaning will not be lost. Delete either west, east, south, or north. You can delete one column. The logic will not change. The three
Yes.
steps. First,
Yeah.
convert the text value into numbers. Then you
Hmm.
expand into number of columns, and then you remove one column so that you don't fall into what you call dummy variable trap.
Right.
Any one column you can remove, west, east, south, or north. Generally, it is easier to remove last or first column, right? So you
Yeah.
remove last or first column.
Yeah.
It will still give us same meaning. When you, okay, so 100 means not is present. Okay, when you have something like 000 here means the fifth column is present. All three are absent. All three absent automatically means that fourth one is present, isn't it?
Right. Yeah.
So this is how we handle categorical value.
Okay. Yeah. Good.
Right?
Yep.
So these are the steps that we perform normally on machine learning. Okay. So now if you go back to, yeah. Okay. So this is, you remove the missing values. Okay. And so now your data set is ready. Okay. The last step is that we convert into training set and test set. We discussed this yesterday.
Yeah.
Right? So
Yeah.
this is the sklearn, okay, sklearn function to convert into data. So when you see here, we are saying that xtrain, xtest, ytrain, ytest. These are the four variables we are passing. I'm saying train, test, split is a function. Train, test, split is a function. This is going to return us four values. Okay, one second, Nikhil.
Yeah.
Sorry, one. Trying to mute you, mute myself.
Sure.
Hey, Nikhil, I'm sorry. I got a call and I had to take this was, sir. Okay. So coming back, you there, Nikhil?
Yeah.
Yeah, sorry about. Let's come back here. So we are dividing this into training set. Okay. So when you say 0.2, that means I'm dividing this into 20% test size. Okay. And 80% of the data will be for training and 20% will be hidden for test. Okay. And this is going to return. Okay. So see, I'm not telling. So if there are 100 rows, I'm not telling which 100, which 20, right? 20% means 20 rows, right? I'm not saying which 20 rows will be the test data or the training data. Randomly, it will take any 20 rows as test and rest 80 will be given as train. So yesterday we spoke, right? We will get data set into 4 parts. Training set, X test, X train, Y train and Y test. Right? So X will have more than one column.
Yeah.
Okay. But Y train and Y test will have only one column.
Right.
Okay. So, with that, we are ready to learn. Okay. So whatever we did yesterday was a long way of doing it. It was because you want to learn pandas. That's why we did that long way. Now to do machine learning, we don't have to do, I mean, of course, panda knowledge is important, but we have scikit-learn using which we can, easily handle it. Okay, so if you are working on your computer, okay, whether it is PyCharm or any other thing, you'll have to install sklearn or scikit-learn. You have to install scikit-learn.
Yes.
Okay, so you will say pip install sklearn. I think Colab, I don't have to do it. Let's see.
Yeah.
Colab already
Yeah.
has.
I mean, yeah, on my Jupyter, like which I'm using now, Jupyter Notebook, like I've already installed this.
So I think there you might have to install it, okay, explicitly.
Yeah.
Using
Yeah.
install.
Yeah. Yeah, I did that actually.
Okay, so let's take a simple data set and we try to implement whatever we discussed.
Okay.
Okay, and then this document I'll share with you. You can practice all these things today. And there's one more data set after this, which is a little more complex. That also you can practice.
Sure.
Okay, so
Good.
let's start. Okay, so here data one pre-process, it is machine learning. It gets so hot here in Hyderabad during this time. And this year is very hot.
Yeah. Yeah, I've heard like the temperature is in 40s, right?
Yeah, it's actually very
during
bad.
the day.
Very bad. Machine learning. Okay. Here we have all the data set here. Okay. So this is designed, data processing is designed for doing this activity. Okay. So we will do this. So here you have, see, salesperson quotation and win is the Y column that we want to predict. So here definitely these values are missing, so we have to handle it. And second thing, we have to do scaling also, because this is double digit and this is in 5 digits, 6 digits, 5 digits. So we'll learn how to do scaling, we'll learn how to do this. It has region also. So we'll also learn how to perform the categorical value on, converting into the categorical value, right? So all the 3 things that we discussed, which is important, okay, we should have to implement on data science project and better pre-processing we can do on this data set. Okay. So there is a raw file here. We will read this data. Okay, so work with this. Okay, so this is fine. I mean, if you want, what happened? Okay, yeah. So if you want to see the outliers, you can give the column name. So we can give column name as okay. The column name. This thing also important. Spelling plus the what do you call it, the case, lowercase, uppercase, right? So salesman is upper salesman. Okay, and then this is inside the list, and other column is the quotation, right? Let's try to see if we have any outliers here. So because the numbers are different, right? Let's first run one and see. So there is no outliers in salesperson, right? More or less data is normal. Quotation. So this also doesn't have any outlier. So outlier thing is fine. Okay. So once we have this, then okay. Now we will divide this into X and Y. Okay, so generally when we start working, because all the things that we discussed, right? Scaling, missing values. See, missing values can be on Y also, but scaling will happen only on X, right? So what we do is first we, convert, we, divide the data set into X and Y. X is the features, Y is the target variable, right? So to do X, I'll say X equal to df dot ilog. Ilog is a function which will help us to get a subset of data set. Okay, so you have two functions here. One is called loc log, another one is ilog. Okay, so I can use ilog or I can use loc log. Okay, so both functions help us to take the subset, and how I remember is, difference between log and ilog. I stands for integer values. So when you use ilog, you give the reference of the column in numbers. Okay, we give the reference in numbers. Okay, and when you are doing log, okay, we should give the name. Okay, column name, quotation, win. Okay, so right now what we'll do is we will use column number only. Okay, so you have df.ilog. Okay, ilog will have colon here. We give colon. Before colon, we tell which all row comma column, right? So which all rows to input here. Okay, and which are columns. Okay, so here it will be columns. So if I give something like this, it means all rows. Okay, starting from 0 up to end. Columns starting from 0 and up to end. Okay, so give me all rows and all columns. Okay, that's what it means. So of course we need all rows, right? So this part we will leave as it is, but we will drop the last column for X. X will be region, salesperson, quotation, not win. So I can say start from 0, and when you want to say start from 0 column, you don't have to mention it. Okay, and go all the way. We want 0, we want 1, we want 2. So we can say 0, 1, 0, 1, 2. So we have to write 3 here, all the way up to 3. So only 2 will be taken. You get it? What I'm saying here?
Yeah.
Okay. All rows. So that's why I didn't put anything. Okay. All rows we want. All whatever 100, 1000, 10 lakhs numbers are there. We want all rows. But columns we want only from 0, from first up to the end. 0, 1, 2 itself. We don't want the third column. So I can say that 0:3, or I can simply say -1. -1 means except -1. See, in Python, the indexing starts from 0 to forward, and also -1 to -2, so on. Okay, so this is 0, this is 1, this is 2, this is 3 index. This is also -1. The last value is also referred as -1.
Okay.
So if you want to get win, you can say -1. If you want quotation, it is -2, -3, -4. It has both forward indexing as well as backward indexing. Java doesn't have, but Python has both forward and backward indexing. So when you say 0, 1, 2, 3, 4, that means you are doing from left to right. And when you say -1, -2, -3, that means you're doing from right to left. So I can say 0 to 3, or I can say 0 to -1. That means up to -1. Don't include -1, so go up to -2. So this will give us 3 columns. X will have 3 columns. And if I say values, it will give us values. So if you want to see, I can say print X. So print X will have the data from here except the win column. So see, it has not values here, not the salesperson and this one. The last column is not there.
Yeah.
And of course, we have NaN, which we need to handle it. Okay. Awesome. So now let's create Y also. Generally, okay, generally we write capital X and small y because X can have more than one column, isn't it? And Y will have only one column. So we write small y, but okay, this is just a variable name. So it is up to us the way we want to do it. Okay, dot iloc. Okay, df dot iloc. All rows and one column. -1 or 3. Right? So only one. So here I'm not doing from to 2. Right? We don't need. Okay, this is it. Okay, so now we have read the data and we have broken into X and Y. Now let's start step 1. Now we want to replace the missing values. Right? To replace the missing values, we are going to use simple imputer. Simple imputer is a function, it's a class actually, okay, which is part of sklearn impute package. So sklearn is a package. Inside that you have impute. Impute has simple imputer class, and we will use simple imputer to replace. One line code will replace it. Okay, so from sklearn dot impute. Okay, import simple imputer. Okay, now we need to create an object, SI object. Simple imputer object is nothing but simple imputer. We are calling the class. Okay, and we'll call the constructor of the class or the init. So simple imputer takes strategy. What is your strategy? Impute. Okay, T, sorry. Okay, impute. Yeah. So it takes a strategy. What strategy you want to implement? So I'm saying missing values. Okay. How do you define missing values? Missing values defined using NumPy NaN. So import NumPy as NP, and I'm going to say missing value is represented as np.nan. And what strategy you want to use? Okay, you say mean. You want to use mean strategy. Okay, so object is created. Now we have to execute the object. Okay, So we have something called as fit transform. So two step, okay? First step is fit, second step is transform. So fit is like telling what you want to do, and transform is executing it. So some object, some class will have fit underscore transform, some will have fit separate and transform separate. As we do, you will see. So first you have to perform fit, then we'll say transform. So this is the object we created, isn't it? Strategy. Now fit. Fit, you have to implement. Implement where, okay? So SI object equal to, okay, SI object dot fit. Okay, here we pass the data set on which we want to, okay, we want to put. So see, it has given X and Y. Okay, so here we say that we want to do it for all the X. Okay, now there's a problem here. Okay, let's do X and we'll see. Okay, now what we do is, so we are saying that we want to fit it on X. So X equal to, the new X will be, the SI object dot transform. Okay, SI object dot transform, and you say X. Okay, now let's run this and see what happens. Okay, we got error. Error is, see, could not convert string to float.
Oh.
See, right? The first column is region, right? And we are saying mean. Mean works only on numbers, isn't it? Not on categorical values. Right? So we cannot pass X. Okay, so in X we will say all rows. We will say, okay, no, this is the output. Here, we will say we want to work on all rows, but first column onwards only, not on all the columns, not on zero column. So you say one column, that zero column is ignored. Right? We are working on
all columns except for the zeroth.
Yes, except zero, right? So, so when you have to replace, if I say X here, then the column will be lost, right? So we'll say same thing here also. Because the column 0, first column has text data. We cannot perform mean. That's why we got this error. Now let's run it. Oops, here also have to do it, right? So we are saying implement strategy on, so executed. Now you see here, NaN, you have this NaN. Okay, so this NaN was done before. One NaN should be on this column also. Now if you run X, now what I'll do is I'll print X here. So I'll say print X after simple imputer. Print X. So see here, this is replaced with the mean value of this. You can calculate it later. This was a NaN, right? 40 NaN. This NaN is replaced with the mean of this data set. Here, next one.
Okay.
And similarly here too. It was NaN here, this was replaced with the mean value of this column.
Okay.
So this is how you can replace. What we did yesterday was using pandas, right? But simple imputer, which is a class inside sklearn impute, you can directly use it you call it to replace the missing values.
And I have a doubt over here.
Yes.
Suppose if we have 0 values, like null values, for example, then what
When
is
you
the
read
function?
the null values, this will convert into NaN values. When you do pandas, right? Pandas will convert null. See, null means what? Blank values, not zero. See, 0 is also a number, isn't it? But when you have null and when you read it like pandas, it will convert into NaN. All the blank will be converted into NaN.
NaN. Okay. Okay.
Right? Even if you have a blank value, and this one also will be as NaN.
Okay.
Okay, and NaN can be read as null values. Like yesterday we did, right? Is null, right? Here we can say replace np.nan with whatever strategy.
Yes, got it.
Right? Yes. Okay, so this first part is done. Now, how to handle the categorical value? So we have something called as sklearn.preprocessing. Okay, just to save some space. Okay, let's comment out these. Okay, let's not. Okay, this output will not be there, so we can view more stuff. Okay, so we will use something called as pre-processing, and in pre-processing we will see how to handle this. Okay. So from sklearn dot pre-processing. Okay, pre-processing. Okay, so remember we did 3 steps. First, convert the text into number, then convert it to multiple columns, then
drop the first.
Delete one column, right? So first we have to do the first step, which is this one here. We are actually pre-processing. Correct? Spelling is correct. Okay. So we are, we'll be doing what is called as label encoder. Label encoder encodes the label. Okay. Automatically it will encode your text into numbers. Okay. So I'm going to call sklearn import, pre-processing import label encoder. Label encoder and one hot encoder. One hot encoder. Let's see the properties of this. So, first thing first, I have to create label encoder object. Okay, so this is equal to label encoder. It doesn't need any parameters. So I'm saying that I'm going to use label encoder. The label encoder object is ready. Okay. Now here to apply on the first column, right? I have to apply this on first column. So I will say X of all rows and first column equal to label encoder object dot fit. Same thing, fit and transform. But here fit and transform are part of same function, right? So fit underscore transform is a function which does both fit and transform. Okay, so label encoder fit transform, and I will pass the values on which I want to do the fit transform. All rows, 0 column. Right?
Yeah.
Now let's run this and see what happens. Print X. You see this?
Yeah.
The north became 1 south became 2, east became 0. So it will do on the alphabetical order automatically. Okay. So since it will first find out the unique values, it will get 4 unique values. Then it will rearrange in the alphabetical order. So you get 4 unique values, rearrange in alphabetical order. He will come first, east will come first. It will replace east with 0, north with 1, south with 2, and west with 3. So this is what label encoder does. But we should not stop here, right? We have to convert what we call it. We call it as a column transformer. We have to transform the column using one hot encoder. See here, label encoder will do 1, 2, 0, 3, 0, 1, 2, 3. But now we have to convert into 1, 0, 0, 1. That's what we use one hot encoder. One hot encoder will use to convert into zeros and ones only. And column transformer is used to transform into multiple columns. Okay, so first we have to transform into multiple columns, isn't it?
Yeah.
So we have to use column transfer, and this is part of sklearn compose. So from sklearn dot compose. Okay, import column transformer. This is what will help us to transform the column. Compose is correct spelling. Why it's showing red line? Yeah, gone. Okay, so column transformer. So what we do here, we have to create column transformer object equal to, we have to pass the parameters, right? So column transformer. Okay, now we'll pass different values. So first it takes a set, list values. Okay, it takes a list values. So I'm going to pass list. Okay, now what does list have? Okay, so this list has which, okay, so again we have to pass this as a tuple inside list. The first value is the strategy that we are going to use. The strategy that we are going to use is first one hot encoder. One hot encoder. My fan is burning, that's why I have to switch it off. It's so hot here. Started giving smell. So one hot encoder. Okay, this is the strategy, and this will be used using one hot encoder function that we are going to use here. So I'm going to copy this, put it here, and I'll put this. So tuple. Okay, so it has tuple of the strategy and which function will help us to implement that strategy and on which column. Okay, so it is on column, first column. So I have to say here 0. So with that, this is the parameter that it takes. Apart from this, we have to give what is called as reminder. Reminder, okay, is like, you know, it is like which all columns should you work on, or which all rows basically. So we say on all the rows. So remainder equal to past row, all the columns. So this is it. Our column transformer is ready. Okay. Now we need to implement it on the data. So see, now what happened is we have converted this first column also into number, isn't it? So we can use X now. We don't have to say X of first column. And we are also mentioning that do it on first column. Right? So that's why other columns will be untouched. If you had to transform on more than one column, you could have said 0, comma. Let's say if you have to do on fifth, we'll say here 4. Because it takes list values. So in our case, we have only one column which we need to do column transform. So here I can safely say x equal to, because even though we are passing all the columns, it is going to transform only column 0, first column. So x equal to, okay, this object that we have, which is CT column transformer object dot, okay, fit transform, both fit and transform will do. Fit transform, and here we pass the data, which is x. Okay. Now, when you run it and print x, let's see what happens. Okay. So you see this, one column became one, two, three columns, 4 columns, isn't it? You see that?
Yeah.
This is because of column transformer. So we performed column transfer 1, column number 0. So it got into 4 columns. Okay.
Then
now you see our output y is in yes or no. Right? Here, label encoder is good enough. We don't have to do column transfer. We just say n as 0 and yes as 1. Because mathematics, it takes, right? This is what you were trying to do yesterday's code that you showed me, isn't it?
Yeah.
In logistic regression thing. So we can simply use column transfer, label encoder, and get it as y. So if you go here, I'm going to say y equal to, okay, but before that, label encoder, right?
Or we can directly fit, can we directly fit transform?
Yes, we can do fit transform y.
Y.
Right? So y equal to label encoder object dot fit transform, okay, and you say y. Right? Now when you print y, it's of zeros and 1. Yes or no, it should have 0 and 1. And again, we know, right? I will comment this out. You see, y 0 1 0 0 1 1 0 1 0. See, the x is 2-dimensional, right? That's why you get set inside set, set, 2-dimensional. We give column also, we give from 2, right? Column we gave 0 2 3, but here we give only one value. So that's why y is only 1-dimensional here.
Yes.
Okay, so we got y also now. Now we have to remove one column from x, isn't it? So here we have done the level encoder. Here itself, I'll say x equal to x, all rows and column from 1. Automatically, the leftmost we have deleted. Whatever is easy for you. So now x is ready, y is ready to get into analysis. Okay, we have to do scalar also, right? Because here we have values, different values in x and y. So what we do is, scaling. Okay, so in scaling, okay, so it is also part of pre-processing. Okay, sklearn pre-processing. So I'm saying from sklearn dot pre-processing import standard scalar. Okay, we'll be using standard scalar. And first, you have to create the object. Okay, standard scalar object equal to standard scalar okay, and then I'm going to say a fit transform. Okay, so created this object. Okay, and now I'm going to say x equal to sc object dot fit transform. Okay, and x. That's it. And if you want to print, we can print x and see whether this has been done correctly or not. Oops. Important standard scalar.
Oh, fit trans.
No. Here itself, it's saying that it doesn't understand standard scalar. So this one. Okay. Okay, maybe spelling was wrong. Let's try again and see. Oh, scalar. Okay, not wrong. That was E. Okay, let's see this. Here also the achievement, right? It transform.
With me.
Cannot center sparse matrices with mean equal to false. Instead, use dogs true for motivation and alternatives. Okay, however, what I'll do here, so 0 we have dropped, so 0, 1, 2. It doesn't matter, it will anyway use this 0, 1, 2, I say 3. Should not be the case. Yeah, cannot center sparse matrices pass with mean. Okay, let's see this. Standard scalar preprocessing. sklearn preprocessing. Standard scalar. See this right. Okay, I think we have to convert this into I think I got it. We have to convert it. Okay, so this is the standard scalar. Same thing we are doing. Okay, so this fellow has done split before and then scalar. Okay, so generally people do split before and scalar, but I prefer to do it after. I mean before and then run it. So okay, with mean equal to false. Let's do that. Yes, it worked. Okay, with mean equal to false. So this is the new data set that we have. Okay, so scaling is done. Now we will do the test train split. Okay, to do the test train split, we use model selection. So from sklearn dot model selection import train test split function. Train test split function. Okay, now we will split it. So it will return us 4 values. First is y and x train, sorry. X train, it takes x and y value and gives us 4 x train, x test, then y train and y test equal to train test split, the function that we are calling train test split. Okay, and here we pass the x value that we have, the y value that we have, then the test size. What should be the test size? Okay, so we say 0.2, indicating 20%, and that's it. So
and, random state.
Yeah, so random state 0, okay, means, you know what, see, the thing is, I told you, right, randomly it will divide this data set into multiple things. So if you have 100 rows and we say 20% test split, right, it can take any 20, isn't it? Any 20 rows. Now let's see if I'm doing it and you are also doing it, and you want to see if your steps and my steps are same or not. You want to make sure that we have done the same thing and we get same answer. So it is, in a way, we are trying to force the algorithm to go through a specific random state. Okay, so it's like this. If I tell you to think a random value, okay, I'll tell you, think of a number between 0, 1 and 10. So you can literally think anything between 1 and 10, but mentally you are following some logic. Okay, so maybe today, whole day you were seeing, 5, 5, 5, everywhere 5, right? you're getting a message 5, you saw some news 5. So that you will tell me, you will think of a number 5. So even though it is random, it is really not random. There is some kind of mathematics which goes behind it. So in Python, or for that matter, any programming language, when you say random value, okay, there has to be some logic, right? Random, how can the computer think of a random? You'll have to give some logic, specific logic. So when we say random state, we are limiting that, that logic. We are limiting that logic. That means if I say 0, and if you also use 0, that means my program and your program will think in same formula. So even though it is random value, but we both will get same answer if you mention random state 0. So while developing the applications and learning, testing, it is better to give random state so that you can get the same answer. When I run it 100 times also, I'll get same answer. Okay, same. Let's say, first 2, then 11th, 12th, then 31st, 32nd, then 50, 55, then 80, 81, 82, 84. These rows are selected, assume. So every time random state is 0, same rows will be selected. So you are forcing the computer to use same formula to think random. So if I say random state 5 and you thought of a number 5, every time I say random state 0, you will get same number 5, 5, 5. So it is good when we are practicing. Okay, when we are learning, it is good so that you also get same answer, I'll also get same answer. That's why we use random state. But when you actually deploy, when you are actually using it, it's better not to give random state.
Okay.
Okay. So now our X test, Y test, Y train, Y test are ready to work on any machine learning algorithm.
Okay.
Okay.
Yeah.
So these are the steps. Okay. I'm going to share this code. I'll also share one more little complex code. Please practice. Okay.
Sure.
And yeah. So I think we are done with preprocessing, right? Next we can start with algorithm, correct? Or anything that you have. So maybe you take a time tomorrow, Monday, you take time to work on it. And then let's see, we can meet on Tuesday.
Yeah, and I was going to ask about that. So, because I work full time, on the weekdays, like during this time, like I'll be working.
Okay.
So
So we can meet next Saturday, right? No worries.
yeah.
Okay.
Yeah, sounds good. Perfect. I'll practice all of this till then, and then I'll if I have any doubts or anything, I can
WhatsApp
compile.
number is there. Yes, you just ping me on WhatsApp, I'll respond.
Yes, and or I can compile all the doubts and then we can discuss on Saturday as well.
Yes, that also sounds good. Yes.
Perfect. And then also wanted to ask, by any chance, are you free in the morning, like at 7:30 or something for
My
1
time?
hour? Yeah.
Yeah. So see, I generally go to drop my wife at 8 o'clock. Okay. So 8 to 8:15, I'll not be available. So what we could do is we can meet from 7 to 8, or maybe 7 to 8, 7:55, take a break for 15 minutes, come back at 8:15. That also we can do. So actually, I had a session in the morning, which I don't have. So right now my mornings are free. So yes, we can meet in the morning. Yeah.
Cool. So yeah, probably we can discuss sometime this week.
Yes.
If there is any free time available for us in the weekdays, then we can probably for 1 hour or something.
Sure.
And also after this, I was thinking once we finish the algorithms and then doing the final analysis on this model, can we please go over, I'm a bit weak in the if loops, for loops, functions, classes.
Yes.
And once we finish this.
Yep. Yes, we can do that. Yeah.
Thank you. Thank you. Yeah.
Sure.
So
Yeah.
we'll be in touch.
Yes,
And if not
definitely.
the weekdays, then definitely on the weekends for sure.
Yes, sure. Yes, yes.
Thank you again.
No problem. Thank you again. My pleasure. And I'll send the recording as well as the content. You should have them. So let me stop recording now, I guess, right? Let me stop sharing my screen and stop recording.